Hi guys, back again here to go over the pre-calculus T.8 notes. This is the trigonometry notes for 8. You will need to remember a little bit about trig before we go into this, especially what like the sign of pi and pi over 2, 0, and 3 pi over 2 are. Those are going to help you a lot, and that's why I'm going to do a little bit of a brief overview of that. Before we get started, I just want to do really small. If we remember the unit circle, we have basically four main positions. We have 0 or 2 pi. We have pi over 2. We have pi. And we have 3 pi over 2. These are like the four main positions, and they hold four values for sine and cosine are concerned. If you remember, cosine deals with the horizontal or the x, while sine deals with the y, the vertical. So in this position, the 0, 2 pi, the cosine is equal to 1, while the sine is equal to 0. In pi over 2's position, the cosine is equal to 0, while the sine is equal to 1. Basically, the point 0, 1, this point's 1, 0. If the middle is 0, 0. This point here, cosine is -1, while the sine is equal to 0. And down here, the cosine is equal to 0, while the sine is equal to -1. Those are your four main positions that you have to care about. And we're going to talk about if we graph something called the y equals sine x. This is what we call a parent function. The very basic form of the sine function. And we're going to see what that looks like. It looks like a wave almost. It's pretty cool. So what I'm going to do is I'm going to just show different positions. And you also see that we have 1 here, and then 2, and then -1 here, then -2. But on the horizontal axis, the x-axis, it's not like 1, 2, 3 like we're used to. We have 0, pi over 2, pi, 3 pi over 2, and 2 pi, just like in this blue circle that we drew over here. And we're going to show why that exists. So instead of putting in things like 1, 2, and 3 for your x, we're going to use pi over 2 and pi and things like that. So let's look. So for example, if we did the sine of 0, what do we get? Well, we know 0 is right here. The sign there is equal to 0. Then the sine of pi over 2, we can see pi over 2 is here, and the sign is 1 there. The sine of pi, we can see right here, is 0. The sine of 3 pi over 2, see right here, is -1. And the sine of 2 pi, that's equal, again, to 0. So let's look. We have sine of 0 is 0. We can put that in. Sine of pi over 2, so we have pi over 2 right here. So we want to go that to 1. So we have 1. Then we have the sine of pi, that's 0. The sine of 3 pi over 2, that's -1. And then again, we have sine pi over 2 pi, and that's here. So we'll see a shape that curves up and down like a wave almost. Like in an ocean, it might go like up and down where a wave crests and falls, just like a sine function will. And we'll see the sine function start at 0, 0. And then, as you can see, it follows this sort of pattern, up and down, up and down. And it's going to keep like going on like this forever and ever and ever. So what we can do is we could see, well, it goes down like a roller coaster, down, then up, then down. It's going to keep going down until it hits this point again. So the next thing is negative pi over 2. So we can assume that it's also -1. So we're going to keep going down. And then we can see what should happen next. Well, it's as far down as it's supposed to get. So then it goes back up, follows the same pattern. And then we can see that it can still keep going up because it should reach this position. So we have it here. So it's going to keep going up like a roller coaster, and then finally drop back down. this is a basic sine function, and what the basic looks like. The big thing here is that we see that it starts at 0, 0, goes up and down, and I'm going to draw these blue lines real quick. You can see that here to here they all have different positions there, and it's like this is what we call a period of a sine function. The idea that all the parts, like if you could broke this up into thousands and infinite amounts of these positions, and it's going to keep going on the same throughout however high we go on the x-axis. And it's never going to go above 1 and never going to go below -1 for a parent function of it. Now the cosine, we're going to do a very similar thing where we look at our blue circle right here. Just going to choose different colors so we can see the difference. Choose purple. So we're going to use that, and we're going to say, okay, what's the cosine of 0? Well, we saw the cosine of 0 be 1, the cosine of pi over 2, the cosine of pi, the cosine of 3 pi over 2, and the cosine of 2 pi. Now we can see right here that we have cosine of pi over 2 is 0, cosine of pi is -1, cosine of 3 pi over 2 is 0, and then cosine of 2 pi is 1. So we're going to graph those the same way we did here. So we have cosine 0. This time it's actually at 1 and not at 0, so it doesn't start at 0 like the sine function does. So it's going to start right here. And then we can see cosine pi over 2 is at 0, so it's actually going to start going down. And then we can see it's at -1, so at pi. So at pi it's -1, so it's going to keep going down. It's going to start going back up at 3 pi over 2 to 0. And then we have cosine 2 pi is 1, so up here. And we can see that we have just the dip part of this. But again, we're going to use, let's use green for this. This is a period, just like it was in a sine function, where we're going to just copy this exact shape as it goes left and right. So if we can see, it goes up, it goes down, then up. So if we go left, it's going to go down here and here. Again, we're just using the same period and drawing the exact same way, but just on the next section over. And that is what cosine function looks like. You can see that it's a little bit different because it starts at 0, 1 and not 0, 0. So it starts in its peak while the sine function starts in the middle of the sine function. So those are the basic forms, the basic parent functions of both the sine and the cosine. All right. So now let's try to graph some functions that maybe use the parent function, but aren't the exact same. They don't look exactly like this, but they're going to be pretty close. And we're always going to want to draw 2 periods of each one to fully do it. I'm not going to do that the entire time because it's just copying it, but I'll show you. So let's look at, for algebraic functions a, h, and k, we were used to perform transformations of parent functions. For sinusoids, we're going to use the following format. So this is what they look like. You can see they're exactly the same, sine and cosine. The only difference is that there's a sine here and a cosine here, but they're exactly the same. So f of x, or as we know it to be y, is equal to a sine b times x minus c plus d. Now, what do all of these letters mean? Well, a is the amplitude, or half the height of the wave. So let's say a wave looked like this. The height of the wave is the idea of how high it is from here to here, right? That's the whole height. So if you say that's 5, or let's say 6, because half of 6 is a little easier to understand. So we have half of 6 is 2.5. So a would be 2.5. That's the idea of the a value. So I just want to show you here, the a value right here is going to be 4, because that's what's in front. So we have a, or amplitude is what we call it. A is equal to amplitude, which is equal to 4 in this case. The negative we're not going to write because it's the absolute value is what we want. So it would be -4, but because it's the absolute value of -4, it's just regular 4, positive 4. The next one is dealing with B and C. Those don't matter by themselves. They are used to find other things. So the graph is reflected over the x-axis if A is negative. So we look to see right here, A is negative, so there is a reflection. So for when we do the tests, all you have to say is if there is a reflection or not. Because A is negative, there is a reflection. And you would say no reflection if A was positive. So the next thing we're going to do is talk about the period. This is probably the most important when graphing these. The period is really, really important. And that's found by doing 2 pi over b. So this is, again, super important. Please pay attention to this one. This is the most important part. The period of the function is 2 pi over the absolute value of b. So let's look. In this case, right here, b is 3. It's the thing next to x. So the period of this is 2 pi over 3. That's the idea. 2 pi over 3. And we're going to get back to that, what that means. There's a phase shift. This is the idea of moving left and right. So if this ends up being negative, it's going to shift to the left. If it ends up being positive, it'll shift to the right. And be aware, this is minus c. So it's going to be the opposite of whatever you see in there. So right now c is actually 0 because there's nothing being added or subtracted inside the parentheses. So 0 over anything, or 0 over 3 in this case, because c is equal to 0, there's no phase shift, so none. And then there's a vertical shift. This is the idea of moving the graph up and down, but because d is also equal to 0, there's nothing being added or subtracted over here, then this is also none. So there are 5 things that you need to know before you start graphing: amplitude, reflection, period, phase shift, and vertical shift. And this is going to be dealing with cosine, sine, tangent, cotangent, cosecant, and secant. They're all going to use these things in common. The period phase shift might be found a little bit differently in different kind of functions, but they're all going to be the same idea. So let's look at this and actually how to graph it. So we're always going to start every single time with 0, 0. That's where it starts, 0, 0. I'm going to use a different color just to look a little nicer, have it stand out differently. So we have 0, 0, and we want to count 4 spaces over. 1, 2, 3, 4. That's going to be a period, a single period. So we will see this is going to be what we're graphing. This little zone is what we really care about. And we know that first point is 0, 0, and this last point is whatever the period is. In this case, the period is 2 pi over 3. So 2 pi over 3. And our goal is to figure out, okay, what should go in each of these 3 other positions that we don't know yet? Well, we know the middle position is always going to be half of 2 pi over 3. This position is a fourth, and this position is 3/4 of this. So a half of this thing, half of that, 2 pi over 3 is just pi over 3. That's half. If you divide that by 2, it's just pi over 3. Then we have half of pi over 3, or a fourth of 2 pi over 3, is pi over 6. And then we have the last one, which is going to be pi over 2, which is, in order to find that, what you could do is do 2 pi over 3, and we know it's 3/4 of that. So what you could say is 2 pi over 3 times 3/4. These completely cancel out. These reduce to 1 and 2, which gives you 1 pi over 2, or just pi over 2. So remember, this is 0, this is 1/4 of the period, this is 1/2 of the period, this is 3/4 of the period, and this is the full period. That's what you have to deal with. Okay, now let's plug some numbers in. So we have an x, we're going to do a table chart, and a y. We know x is always going to be whatever these values are. So we have 0, pi over 6, pi over 3, pi over 2, and 2 pi over 3 as our 4 positions. And our goal is to figure out what the y value would be at each of those positions. So I'm going to draw some lines here so that way we can break it up so we're not confused. Okay, cool. So what if we have 0 in here? Well, if that's the case, if we have 0, we're going to plug in 0 here. So we have -4 sine of 3 times 0, which is 0. And what does that equal? Well, you have to remember sine 0, so that sign on the far right hand is 0. So -4 times 0 is 0. So we know the first position is 0, 0. That's good. We have that point right here. And now we have pi over 6. So let's plug in pi over 6. So we have -4 sine, and we have to say, okay, what's pi over 6 times 3? Well, pi over 6 times 3 is pi over 2. So we say, okay, what's the sine of pi over 2? Pi over 2 is that top position. So the top position gives us 1 for sine. So 1 times -4 is -4. So we have -4 here. So we know our first thing is going to be to go down here. Then we do -4 sine of 3 times pi over 3, which is just pi. And we know the sine of pi is 0, so this is another 0, so it's going to go back up to here. And then we'll do the next one, which is -4 sine of pi over 2, but we have to multiply that by 3. So we have 3 pi over 2. Sine of 3 pi over 2 is -1, so -1 times -4 is just 4. That goes up here. And one trick you can always know is that 0 and the 0 and the last period, the last point right here, will always be the same outcome for y. So if that's the case, if this was 0, this one will also be 0. So we go all the way down here. So this is how we graph a single period of this function. What I'm going to do is I'm going to erase the left-hand side right here and make sure you write this down if you're confused about it, or go back to the other part of the video. But I'm going to erase this so I can draw 2 periods of it, because on your test, I will be expecting you to draw 2 periods of each of the things that you graph. So let me erase that real quick. I know it's going to be a little tedious. Okay. So then if I want to just draw another period, I just want to go the same path. So if we go from left to right, or right to left, we go up, then down all the way, then up. So we got to keep going up. So we go up to here, and then back down, and then all the way down, and then back up. And as you can see, when you do this, you create the same motion over and over again, the same wave. Cool. Now let's just practice a couple of them. So now we have a cosine. Again, very, very similar to the sine portion of it. So we want to do amp first. What's the amp here? The amp is 2. There is a reflection because of the negative here. The A is 2. And we know the period is always 2 pi over b, as we did right here. 2 pi over b. The b is 1 in this case, so the period will be just 2 pi. The phase shift is nothing because there's nothing being added or subtracted inside of the parentheses, so none. There is a vertical shift, though, a vertical shift of -1 or -1, so we go down because we can see that -1 there, pushes the graph down. All right, let's just try to graph it. We're going to do the exact same thing as we did before, where we have x's and y's, and we're going to figure out what they are going to be. So we're always going to start with 0 and count 1, 2, 3, 4 over, and that's the end of the period, which is 2 pi right here. And then we want to figure out what these are. Remember, this is 1/4 of that, this is 1/2, and this is 3/4 of 2 pi. So 1/4 of it, or sorry, 1/2 is just pi. 1/2 of that, or 1/4 of that, is pi over 2, and this is 3 pi over 2. Okay. Again, we're just drawing the positions out. And now I'm going to figure out what the graph's going to look like. I plug in these things, pi over 2, pi, 3 pi over 2, and 2 pi. So we have 0, pi over 2, pi, 3 pi over 2, as well as 2 pi. So if I plug in 0, here's what it looks like. -2 cosine of 0 minus 1. Oh, what's the cosine of 0? That's what you have to ask yourself. Cosine of 0 is 1. So 1 times -2 is -2. -2 minus 1 is -3. And if you remember, the first and the last are always going to be the exact same thing. So we know we have 1, 2, 3. That's -3 right here. So it's going to start here and also end there. And now our goal is to figure out what the other positions are going to be. So if I plug in pi over 2, I get -2 cosine pi over 2 minus 1. And what that looks like, -2 cosine pi over 2. Cosine pi over 2 is 0, so 0 times -2 is 0, 0 minus 1 is -1. So we have -1 right here, so that's -1. And we plug in pi, -2 cosine pi, then minus 1. Cosine pi is -1. -1 times -2 is 2. 2 minus 1 is 1. So it goes up to 1 now. And then let's see. It's probably going to go down. So now we have -2 cosine of 3 pi over 2 minus 1. We know cosine of 3 pi over 2 is 0. So 0 times -2 is 0. So it's -1. So we can see this goes like that. This is what we consider one period. And if you wanted to draw more than this, you could just copy this exact shape over and over and over again. I'm not going to do that here, but if you were going to draw more than one period, you would just copy it on each other section. So this is a cosine function looking like this. As we can see, it shifted 1 down than where it's supposed to be. So that's pretty interesting. Cool. The period is 2 pi. Let's do the next one. So this one, we have y equals the negative sign of 2x plus pi plus 1. So now we can see that there's a c value. A is equal to 1, b is equal to 2, c is actually equal to negative pi. Remember, it's the opposite of whatever this is, and d is equal to 1. Okay. So then we're going to do the amp. We know the amplitude is 1. There is a reflection. The period is 2 pi over b. B in this case is 2, so that's just pi. We know the phase shift is going to be c over b. So c is negative pi and b is 2. So we know the phase shift is negative pi over 2. So it's going to shift the graph left pi over 2. And then last but not least is the vertical shift. And that one's easy, just 1 1 up. Cool. And now using these things and also showing what this is going to be. So we want to start at 0. We want to end at pi. Remember, 1/4, 1/2, 3/4. So 1/2 of pi is pi over 2. That's easy. And then 1/2 of that is pi over 4. And then 3/4 of this is 3 pi over 4 as the 4 different positions that we have other than 0. All right, so we have x and y, making our table. So we start with 0, then pi over 4, pi over 2, 3 pi over 4, and just pi. Remember, I got these numbers just from these right here, and you start with 0, and you end with the last part of the period, which is pi in this case, and then you figure out these 3 numbers based on 1/4, 1/2, and 3/4 of the period. All right, plug in 0 to the function, so we have negative sine 2 times 0. I'm not going to do that. Make it a little cleaner. 2 times 0 is 0 plus pi is just pi plus 1. And we know sine of pi, or negative, so sine of pi is 1, or sorry, 0. Sine of pi is 0. So 0 plus 1 is just 1. So 0, 1 is going to be our first position. Then we have pi over 4. So we have negative sine. So pi over 4 times 2, because we're plugging it in, pi over 4 times 2 is pi over 2. And pi over 2 plus pi is equal to, let's see, pi over 2 plus pi is 3 pi over 2 plus 1. And 3 pi over 2, we look at the sign of that. So the sign goes down, so it's negative 1. Negative 1 times negative 1, or the negative, so it's positive. So that would be equal to 2. Because this thing right here is equal to 1. Because 3 pi over 2, the sign of that is just negative 1. So negative 1 times negative 1 is 1. 1 plus 1 is 2. Next, we have pi over 2. So we have negative sine. And we know when we plug in that, pi over 2 times 2 is just pi. So pi plus pi is 2 pi plus 1. And we have 2 pi. The sine of 2 pi is 0. So 0 plus 1 is just going to be 1. We have negative sine. Again, we're going to plug in 3 pi over 4, multiply that by 2, so we have 6 pi over 4, plus pi is 10 pi over 4, which ends up being, let's see here, negative 1. So this is going to be the same as 3 pi over 2, and plus 1. So that's negative 1 for sine 3 pi over 2, and then times negative is positive 1, so 1 plus 1 is 2. And last but not least, this ends up being 1 again. So we can see 0, 1, pi over 4, 2. Then we have 1 here. Oops, that was my mess up. Actually, it's supposed to be down here and then here. Let's go look at that, because I did mess up on this one. It's not 3 pi over 2. So this one should be, I'll do the work over here for it. We have 2 times 3 pi over 4 and plus pi. So 2 times 3 pi is 6 pi, so we have 6 pi over 2 over 4, plus pi. We know pi over 4, 6 pi over 4 is the same thing as 3 pi over 2 plus pi. And we add those together, and then we're going to get what, 5 pi over 2. Oh, and that reduces to, let's see, a full rotation, so we can get rid of 2 of them, so just 3 pi over 2. So, all right, never mind. Yeah, 3 pi over 2. All right, I'm just planning this thing for a second. Pi over 5 pi over 2. A full rotation around would take out 2 pi. So it would just be like pi over 2. Okay. So if we 2 full rotations around, so we have just pi over 2 is the thing we have to care about. So this becomes pi over 2. The sign there is 1. So 1 times -1 is negative 1. -1 plus 1 is 0. And that's what we have to care about. So here is our graph. All right. Cool. And then remember, this is a single phase. You can copy this over. Or single period. All right. Let's go with number 4. Number 4 says, I'm going to erase this so I have room to do this last one. This one's going to look a little bit different to you because you'll see just regular numbers on here instead of the pi's that you're used to. One of the fun things about technology is sometimes it's very slow. All right, cool. Let's go. We have this function right here. We know the amp or the A value is 3. There is a reflection. And the period, the most important part, the period right here is the B value is pi over 3. So what you do is take 2 pi over pi over 3. So this is the same thing as doing 2 pi times 3 over pi, which would cut these out. So the period is actually just 6. 2 times 3, 6. Again, it's 2 pi over 3. So that's the same thing as doing 2 pi times 3 over pi. These pi's cancel out, so just 2 times 3 is just 6. So we know this is going to be 6. This is going to be 0. We know the phase shift is C over B. There is no C, so none. And the vertical shift, that's just 1 up. All right, let's look. So half of 6 is 3. Half of that is 1.5. And 3/4 of 6 is 4.5. So those are the numbers you're going to use. So you have x and y, 0, 1.5, 3, 4.5, and 6. So we have -3 cosine of 0 plus 1. Cosine 0 is 1. 1 times -3 is -3. -3 plus 1 is -2. Then we do -3 cosine of 1.5 times 3. So 1.5 times, or sorry, pi over 3. So that's going to be, let's see here, 1.5 times pi over 3. So we have pi over 3 times 3 halves. These cancel out, giving you pi over 2. So we have pi over 2 plus 1. Cosine of pi over 2 is 0. So 0 times -3 is 0. 0 plus 1 is 1. So you have 0, -2 right here. Right? And then we have the next one, which is 3. -3 cosine 3 times pi over 3 is just pi plus 1. Cosine pi is -1, so -1 times -3 is 3. 3 plus 1 is 4. So we have 4 up here. This one is -3 cosine 4.5 times pi over 3. Ends up being the same thing, pi over 2. And then plus 1. Oops. That ends up being 1. And the last one is the same thing as 0, so -2. So you have 1, then negative 2. And we can see this cosine function is much taller than the normal cosine function. There we go. And again, the period, you just copy this over. And just a couple things to point out. The amplitude is the idea about halfway. So this is halfway. This is the A value, the amplitude, that you have to care about. So just so you understand where that comes from. The period is the full distance away. Phase shift, how far it moves left and right. And the vertical shift is how much it moves up and down. So now we're going to draw our own functions or write our own functions. So we know A is equal to 2. There is no reflection, so it's going to be positive. So we just say, okay, y equals, we know the A is 2. We know there's no reflection here, so just 2, not negative. We know it's a cosine function, so those are already set up. We know it's a vertical shift of down 3. That's really easy, so we have negative 3 here. So the only thing we have to care about right here is what goes inside. Well, we know that, again, the base function is y equals negative a cosine of bx minus c plus d. Okay. Well, there is no phase shift, so we don't have to care about c at all. It's just 0. But we do have to care about the period. The period is 3 pi. Okay, so we know 3 pi is the period, and we know the period is 2 pi over b. And as we see here, all we have left is just one variable. So what you do is cancel out pi here, cancel out pi here. Just have 3 equals 2 over b. And it's just a simple algebra problem. B times 3 is 3b divided by 3 each side. B equals 2 over 3. So we have 2 over 3x as the inside of that. This is how you create a function. The idea is that your goal is to find A, B, C, and D, and that should be able to write it, and also depending on if it's a reflection or not. All right, last one. This is a sine function, so it's really important that we go up and look what a sine function is supposed to look like. So this is the sine function, and we can see it starts at 0, 0. Well, as we can see here, this doesn't start at 0, 0. So it's going to be a little weird in some sort of way. So again, looking at the sine function, the middle here, and we can see also the top of it hits the x or the y-axis, and that doesn't happen either. So there's some sort of shift both up and down. All right, so the first thing to look at is the period. So from this position to when it hits that position again, how far is that away? The period is from 0 to 2 pi. So the period is 2 pi, which means that's equal to 2 pi over b, which in that case, b has to be 1. So we know the first one. B is equal to 1. That's something we have to know. We know this is a sine function. Okay. You can see that it is not reflected, so we're not going to deal with that. So we have the sine functions. We need still need the a value, the c value, and the d value. Okay. So let's look at a couple different things. We have to look at where the halfway point is here. So from the amplitude, from the very bottom to the very top, how much is that? 1, 2, 3, 4, 5, 6. So we know the full height from here to here is 6. That's the full height. So half of that is the a value, so it's 3. The amplitude is 3. And that's about this position across. Okay, so now we want to find the phase shift as well as the d. So the d is really easy. You just say, okay, from that middle point, how did it transfer from 0 in a sine function? And it transferred 1. So d is 1. And the last one is the phase shift. Basically, how far in the sine function did it move from left to right? And we can see that's pi over 2. In this case, it moved left. As we can see, sine functions should have a little hump as soon as it starts from 0, but as we can see here, it had to shift a little bit left, so that's negative pi over 2, and then you can write out your function, which ends up being y equals 3 for the a value, and we know it's sine. We know the b value is 1, so it's just 1x, and we know the c value is negative pi over 2, and lastly, you have plus 1 for d. And that's it. I understand this problem especially might be a little bit difficult to understand, but the rest of them, like all of these functions are basically the exact same thing over and over and over again. And this one shouldn't be too hard to figure out. If you have any questions, let me know. I hope you have a great day and study hard, guys.